Today is Wednesday, February 26th. So my payday is over. So I have to turn to go into the savings mode. I have to persevere for a month. But luckily, we have a holiday next Monday. So it will be a 3-day holiday. But if I take my personal holiday on Friday, I would have 4 days to myself. I will go down to Gwangju and till the land to sow cabbages and other species for summer harvest. And also I will help with some restaurant to manage their interior design. And also I would be with my family. My wife has stopped calling me for a month, so I think our mutual interest is starting to fade away. But that's personal issue. I'm okay with that. I'm down with that, using the American colloquial express. I would like to read his article. It's rather long, so I should hurry up. I only have 30 minutes to myself this morning. I'm inside in the our labor union office as usual. It's quite spacious. I use this room by myself. No one is here. Our labor union has moved to some other area, so this room is available for the time being. It's a good place to practice English by reading it aloud and also roaming around inside the room. I will just read this article to learn more about RDBS and also to practice English. Here we go. Would you like to visit an Oracle country site close to you? Not yet. This article is from Oracle.com, very pronounced, very famous company, database company out of America. What is a relational database, RDBMS? It's not just a table which is fixed. You cannot move the elements inside the table called records or data. But with a relational database, you can just manipulate rows or columns of data, or even the items inside the rows or in the columns, so that management of the items or data is quite easy, and it expands your capability, right? You can manage the database at scale. What is a relational database, RDBMS? This article was written on June 18th, 2021. What is a relational database? A relational database is a type of database that stores and provides access to data points. Okay, so it is called data points that are related to one another. Relational databases are based on the relational model, an intuitive, straightforward way of representing data in tables. In a relational database, each row in the table is a record with a unique ID called the key. Okay, so the unique ID is called the key. The columns of the table hold attributes of the data, and each record usually has a value for each attribute, making it easy to establish the relationships among data points, right? Data points, keys, right? The keys, record called the key, columns hold attributes of the data, attributes. Industry's best RDBMS. I agree. A relational database example. Here's a simple example of two tables a small business might use to process orders for its products. The first table is a customer info table. So each record includes a customer's name, address, shipping and billing information, phone number, and other contact information. Each bit of information, each attribute, is in its own column, and the database assigns a unique ID, a key, to each row. Unique ID or key, right? Key in, key out, right? Keys. Or key in, type in. In the second table, a customer order table, each record includes the ID of the customer that placed the order, the product ordered, the quantity, the selected size and color, and so on, but not the customer's name or contact information. Exactly, it would be cumbersome, right? You only use the key, the ID. These two tables have only one thing in common, the ID column, the key. But because of that common column, the relational database can create a relationship between the two tables. Then, when the company's order processing application submits an order to the database can go to the customer order table, pull the correct information about the product order, and use the customer ID from that table to look up the customer's billing and shipping information in the customer info table. The warehouse can then pull the correct product. The customer can receive timely delivery of the order, and the company can get paid. How relational databases are structured. The relational model means that the logical data structures, the data tables, views, and indices are separate from the physical storage structures. What does it mean? The relational model means that the logical data structures, the data tables, views, and indexes are separate from the physical storage structures. This separation means that database administrators can manage physical data storage without affecting access to that data as a logical structure, right? For example, renaming a database file does not rename the tables stored within it. That's sweet, right? The distinction between logical and physical also applies to to database operations, which are clearly defined actions that enable applications to manipulate the data and the structures of the database. Logical operations allow an application to specify the content it needs, and physical operations determine how that data should be accessed and then carries out the task. To ensure that data is always accurate and accessible, relational databases follow certain integrity rules. For example, the integrity rule can specify that duplicate rows are not allowed in a table in order to eliminate the potential for erroneous information entering the database. Erroneous or erroneous. The relational model. In the early years of databases, every application stored the data in its own unique structure. When developers wanted to build applications to use that data, they had to know a lot about a particular data structure to find the data they needed. These data structures were inefficient, hard to maintain, and hard to optimize for delivering good application performance. The relational database model was designed to solve the problem of multiple arbitrary data structures. The relational data model provided a standard way of representing and querying data that could be used by any application. From the beginning, developers recognized that the chief strength of the relational database model was in its use of tables, which were an intuitive, efficient, and flexible way to store and access structured information. Over time, another strength of the relational model emerged as developers began to use a structured query language, SQL, to write and query data in the database. For many years, SQL has been widely used as the language for database queries. Based on relational algebra, SQL provides an internally consistent mathematical language that makes it easier to improve the performance of all database queries. In comparison, another approaches must define individual queries. In comparison, from the beginning, in comparison. Right, this is good expression. Very succinct, short, only 2 words, but it says everything. In comparison. Other approaches must define individual queries. Benefits of relational database management system. The simple yet powerful relational model is used by organizations of all types and sizes for a broad variety of information needs. Relational databases are used to track inventories, process e-commerce transactions, manage huge amounts of mission-critical customer information, and much more. A relational database can be considered for any information needed in which data points relate to each other and must be managed in a secure, rules-based, consistent way. This is good expression, man. Right? Here, must be managed in a secure, rules-based, and consistent way. Yeah, you can omit and in the standard grammatical structure. You need to use like in a secure, rules-based, and consistent way. But if you omit and, it just emphasizes the secure, rules-based, consistent way. And it makes it easier to understand, and it makes it stand out. Relational databases have been around since the 1970s, so it's not a new technology. Today, the advantages of the relational model continue to make it the most widely accepted model for databases. Relational model and data consistency. The relational model is the best at beginning the relational model is the best at maintaining data consistency across applications and database copies called instances. Database copies called instances. For example, when a customer deposits money at an ATM and then looks at the account balance on a mobile phone, the customer expects to see that deposit reflected immediately in an updated account balance. Relational databases excel at this kind of data consistency, ensuring that multiple instances of a database have the same data all the time, right? Multiple instances of a database have the same data all the time. So database copies are called what? Instances, right? Database copies called instances. Let's remember that word. You encounter a lot of that expression in a technical documents. It's difficult for another types of databases to maintain this level of timely consistency with large amounts of data. Some recent databases, such as NoSQL, can supply only eventual consistency. Under this principle, when the database is scaled or when multiple users access the same data at the same time, the data needs some time to catch up. Eventual consistency is acceptable for some uses, such as to maintain listings in a product catalog, but for critical business operations such as shopping cart transactions, the relational database is still the gold standard, right? It's still the gold standard. Still the gold standard. Eventual database, commitment and atomicity. Atom, right? We know the atom, atomicity. But let's learn about the pronunciation. Never heard of atomicity, right? Atomicity, atomicity. Power of an atom, atomicity.
Atomicity.
Atomicity, atomicity.
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 Atomicity. Power of the atom, right? Commitment and atomicity. Relational databases handle business rules and policies at a very granular level, with strict policies about commitment, that is, making a change to the database permanent. For example, consider an inventory database that tracks 3 parts that are always used together. When one part is pulled from inventory, the other 2 must also be pulled. If one of the 3 parts isn't available, none of the parts should be pulled. All 3 parts must be available before the database makes any commitment. A relational database won't commit for one part until it knows it can commit for all 3. This multifaceted commitment capability is called atomicity. Atomicity. Atomicity is the key to keeping data accurate in the database and ensuring that it is compliant with the rules, regulations, and policies of the business. Atomicity. I think it's not a power of the atom, but like a atomical atom, very granular, minuscule, right? So let's go back and research more about this word. I would just go to dictionary.com this time. Atomicity, right?
Atomicity.
Atomicity, the number of atoms in a molecule of a gas, right? Granular, right? Atomicity, the items, if the correct set of items are available, then it starts to commitment and atomicity. Atomicity of certain chemical bodies do not inform us as to why one should be a deadly poison or another perfectly innocuous. Right? It will be shown that Clerk Maxwell also definitely affirms the atomicity of ether, while Tyndall and Huygens also use the term particles of ether over and over. Atomicity. So I go back. ACID properties and RDBMS. 4 crucial properties define relational database transactions: atomicity, consistency, isolation, and durability, typically referred to as ACID. Atomicity defines all the elements that make up a complete database transaction. Consistency defines the rules for maintaining data points in a correct state after a transaction. Isolation keeps the effect of a transaction invisible to others until it is committed to avoid confusion. Durability ensures that data changes become permanent once the transaction is committed. Durability, isolation. Durability, isolation, consistency, right? Atomicity. Stored ACID, stored procedures and relational databases. Data access involves many repetitive actions. For example, a simple query to get information from a database may need to be repeated hundreds of thousands of times to produce the desired result. These data access functions require some type of code to access the database. Application developers don't want to write any code for these functions in each new application. Luckily, relational databases allow stored procedures, which are blocks of code that can be accessed with a simple application call. For example, a single stored procedure can provide consistent record tagging for users of multiple applications. Stored procedures can also help developers ensure that certain data functions in the application are implemented in a specific way. Database locking and consistency. Conflicts can arise in a database when multiple users and applications attempt to change the same data at the same time. Locking and concurrency techniques reduce the potential for conflicts while maintaining the integrity of the data. Locking prevents other users and applications from accessing data while it is being updated. In some databases, locking applies to the entire table, which creates a negative impact on application performance. Other databases, such as Oracle relational databases, apply locks at the record level, leaving the other records within the table available, helping ensure better application performance. Concurrency manages the activity when multiple users or applications invoke queries at the same time on the same database. This is good expression, right? Invocation, invoke queries at the same time on the same database. You invoke ghosts, right? Channelers use invocation, and they use chanting, right? Invoke queries at the same time on the same database. This capability provides the right access to users and applications according to policies defined for data control. Right, concurrency. Yeah, concurrency, no problem, right? What to look for when selecting a relational database. The software used to store, manage, query, and retrieve data, right? Store, manage, query, and retrieve, invoke, retrieve data stored in a relational database is called a relational database management system, RDBMS, right? That's good definition of RDBMS. The software used to store, manage, query, and retrieve data stored in a relational database is called a Relational Database Management System, RDBMS. RDBMS provides an interface between users and applications and the database, as well as administrative functions for managing data storage, access, and performance. Right? Several factors can guide your decision when choosing among database types and relational database products. The RDBMS you choose will depend on your business needs. Ask yourself the following questions. What are our data accuracy requirements? Will data storage and accuracy rely on business logic? Does our data have stringent requirements for accuracy, for example, financial data and government reports? Do we need scalability? What is the scale of the data to be managed? And what is its anticipated growth? Will the database model need to support mirrored database copies as separate instances for scalability? If so, can it maintain data consistency across those instances? Right? How important is concurrency? Will multiple users and applications need simultaneous data access? Does the database software support concurrency while protecting the data? What are our performance and reliability needs? Do we need a high performance, high reliability product? What are the requirements for query response performance? What are the vendor's commitments for service level agreements, SLAs, or unplanned downtime? That's good expression, man. Yeah, unplanned downtime. What are the vendor's commitments for service level agreements, SLAs, or unplanned downtime? What are the vendor's commitments for service level agreements, SLAs, or unplanned downtime? The relational database of the future, the self-driving database. Over the years, relational databases have gotten better, faster, stronger, and easier to work with, but they've also gotten more complex, and administering the database has long been a full-time job. Instead of using their expertise to focus on developing innovative applications that bring value to the business, developers have had to spend most of their time on the management activity needed to optimize database performance. Today, autonomous technology is building upon the strengths of relational model, cloud database technology, and machine learning to deliver new type of relational database. The self-driving database, also known as the autonomous database, maintains the power and advantages of the relational model, but uses artificial intelligence, machine learning, and automation to monitor and improve query performance and management tasks. Autonomous database or self-driving database. The autonomous database, self-driving database. For example, to improve query performance, the self-driving database can hypothesize and test indices to make queries faster and then push the best ones into production, all on its own. The self-driving database makes these improvements continuously without the need for involvement. Autonomous technology frees up developers from the mundane tasks of managing the database. For instance, they no longer have to determine infrastructure requirements in advance. Instead, with a self-driving database, they can add storage and compute resources as needed to support database growth. With just a few steps, developers can easily create an autonomous relational database accelerating the time for application development. So autonomous technology, right? The self-driving database can hypothesize and test indices to make queries faster and push the best ones into production on its own. Okay, thanks for listening. We have a meeting 2 coming up. Bye-bye.